Hey everyone, welcome back to another episode of the Weekly Coder. I'm Chris, and today, this week, we are going to continue on with our Game of Life tutorial. We're on part 2, and that means we are going to create some scripts, right? So let's jump right in, huh? Let's create the first script, and we're going to call this one Game. And we're going to create another one, just to kind of be proactive and efficient. I'm going to call this one cell. And then, what are we going to do? We're going to create an empty game object. I'm going to call this game. I'm going to drag the game script onto that. Perfect. Alright. So, what shall we program first? Let's go ahead and start with cell. Okay, so the one thing, or both, we're not going to need in the cell script, we're not going to need start or update. So we're not going to need start or update, and I am so sorry guys, but my server just rebooted. We're having some power issues. Hopefully, not going to lose power. So, we're not going to need this. We're not going to need the start or the update methods. So what we'll do is we are going to need a Boolean value, and that is going to be called isAlive. And we're going to set its initial state to being false. And the other one we're going to need is we're going to need to keep track of how many neighbors each cell has. Okay? And then the only other thing that we actually need in this class is we're going to need to create a method to actually set whether or not a cell is alive. And we're just going to pass in a Boolean parameter that's going to be true or false. And so here we're going to set isAlive. Oops. isAlive. We're going to set that to alive. And then we're going to say so if we're passing, and if alive is true, then we're going to get the component, the sprite renderer component to be exact. And we're going to set the enabled property equal to true. And then if we are passing in false for active, we are going to actually set the enabled property of the sprite renderer on the component to false. Because this will be an easy way for our cells to exist, right, in our scene. And at the same time, we can basically state that, hey, you know, the cell is alive or it's dead. And if it's dead, the sprite renderer basically is disabled. If it's alive, the sprite renderer is enabled. So we either see the cell or we don't see the cell. And that's basically all we need. We don't want to instantiate and destroy game objects continuously. I think that's going to be way more processor intensive than just setting in a property of a component of that game object, right? So I'm going to go ahead and save that one and go and open our other one. Let's see where we are here. Unity, where are you? Okay. So before we open this game class, let's go ahead and set the cell class on our prefab. All right. So what we want to do is go to the prefab, and then we'll just add component, and we'll look for cell, which is the script we just created, right? And that is now there. So now we can go back to scripts, and we can open up game. All right. So first thing that we'll do in this class is we are going to create some static integers that'll hold our screen size. Okay, so we're going to do a private static int, and we'll call this screen width. I'm going to set that equal to 48. And another one, and we'll call this one screen height. And I'm going to set that one equal to 64. And that is actually wrong, because that's supposed to be 48 and this is supposed to be 64. So the screen width is the longer one, the screen height is the shorter one. So this actually equals 1024 pixels and 768 pixels. Okay. So I feel like we just did this, but we're gonna do it again. Man, why does everything I write have some sort of multi-dimensional array? But here we go. So we're gonna use the cell class that we created, and that's gonna hold our x and y coordinates. Okay, and we're gonna call this, just call it grid, and we're just gonna instantiate a new cell, and we're gonna pass in the screen width and the screen height. So that'll be x and y. Y will be the height and x will be the width. Okay, and that's basically, you know, standard on any graph. When you look at x, it always goes from left to right. When you look at y, it always goes up and down. So what do we want to do? We need to, first of all, we need to place our cells. Okay, place cells. Now that's a method that doesn't exist yet, so we're going to go down here and we're going to create it. Place cells. All right. So the best way to place our cells is let's loop over x and y. So we'll start with y. So we'll go for int y is 0 and y is less than screen height. Right? Y plus plus to increment our y at each iteration. And we do for int x equals 0, x is less than the screen width. Okay, and then we're going to increment x. So basically this is just saying, hey, for every y, we're going to increment x, and x, and x, and x, and x, and x, and then we're going to increment y, and then we're going to do x's all again. So this basically iterates it over our entire screen. So again, that's 64 rows, or columns, 64 columns and 48 rows. So for every time that we do that, we want to place a cell. So we're going to instantiate a cell by using our instantiate method. And we're going to use resources.load. And we are going to pass in prefabs and give it the name of the prefab and tell it what type it is. And it's basically cell type. So we created that. And then we're going to pass in, and we can just actually pass in a vector 2. I know I've done vector 3s in the past, but we could just do a vector 2, and it'll by default put a 0 in for z. So we're going to just pass in x and y. And then we still have to tell it quaternion.identity for the rotation. And we are going to instantiate this as a cell. Okay, no red lines anywhere, perfect. So the next thing we need to do is we need to we need to set this cell as a cell in the grid. So X, Y, whoops, equals cell. So right now, the way it stands, this should fill in our entire screen with black squares. So our screen should be black if we run this. So let's go into Unity and have a quick look. Let's go ahead and click play. And it's not doing it. We're calling place cells. And cell. What's happening? Saved. They're both saved. Game script. Game script. Why is this empty? This makes no sense. I can't save it. Why can't I save it? What is happening? All right. I don't know what's happening, but I think I'm just gonna close. I copied everything out of here. And I'm gonna just reopen these back up and see if I can save them then. Alright, so what we've got here. Alright, so basically I'm just going to copy and paste everything back in. That was such a weird glitch. Alright, so copy over that. Save. And copy this. And save. Okay. So there's basically everything we did so far. There's everything we did so far here. Now let's go into Unity. And hopefully, yeah, okay, so you see now there's stuff in those files. It was weird that it didn't save it. Okay. So now if we press play, all black. That's pretty cool, right? So where are we at? 15 minutes? Let's do one more thing before we move on to the next, or before we end the tutorial. I'm trying to keep these a little shorter, but you know, you know how things go. So let's go back to the game, and so instead of filling the entire screen with black, right? For every cell, they shouldn't all be alive. They should all kind of just be randomly generated, right? So basically, the way that we want to do that is we want to create randomness, right? So void, actually let's return bool, and let's say get random alive cell. So what we're going to return is either a 1 or a 0 to tell us whether or not the cell is alive. And the way that we're going to do that is we're going to generate a random integer So it's going to be rand, call it rand, and then we'll do unity dot, unity engine. Oh my god. Unity engine dot random dot range. So because Unity has are both C#, the system.collections, and Unity engine both have a random class, we have to call Unity engine to basically make sure that we don't get an ambiguous namespace error, because it wouldn't know which random class to use. So we're telling it to use the random generator in the Unity engine class, or the Unity engine namespace. So now that we have range, we're going to define our min and max. So what we're going to say is just 0, and I'm going to do 100. And so you can kind of play around with how this randomness happens, but I'm just going to say if rand is greater than 75, then we're going to return true. Otherwise, we're just going to return false. Okay. And then what that's going to do is it's going to create a random number between 0 and 100. And then we're going to say, hey, if the random number is greater than 75, we're going to return true, meaning a 1. If it's not, then we're going to return false, or 0. So then all we need to do is go in here and say grid xy dot set alive, and then we're just going to get a random alive cell. So basically what that's going to do is it's going to say, hey, the cell that it's going to be at grid xy is going to be either alive or dead based on the random integer that was obtained through the random.range method. All right. So now if we save this and go back and run, we should have definitely some randomness. So there's that. Okay. So now we've got a bunch of random squares in our screen. So all of the game objects are still there. They're all created, but some of them are just not alive. So if we can verify this, if we just go like, let's click on this one, you can see that the is alive property is checked. If we go to one that's next to it, we can see that it is not alive. Okay. So the next tutorial, we're going to cover how to basically, what are we going to do? I think we're going to finish it. Next tutorial, we're going to finish it. This tutorial took what, maybe about 20 minutes. I'm sure we could finish it. Next tutorial is going to be about 20 minutes. We're going to do some, we're going to have to check all the neighbors, right? We're going to count all the neighbors around each cell, and a neighbor being, see, each cell has a neighboring cell, but we just care about which ones are alive, because the rules in Conway's Game of Life state that if a cell, actually, you know what, let me just read this to you from the internet so that I don't screw it up. Where is my window? Let's see here. Game of Life rules. So, nope, that's not the right game. Search for Conway Game of Life. All right. Any live cell with 2 or 3 live neighbors survives. Any dead cell with 3 live neighbors becomes a live cell. All other live cells die in the next generation. Similarly, all other dead cells stay dead. So there you have it. Those are the rules, and those are what we're going to need to check. Once we go through and we count all the neighbors for each cell, so meaning all the live neighbors for each cell, we can then go through again, and for every one that doesn't meet our specification, we can either tell it whether it's going to be alive or dead. And then that's basically it. We throw it in the update loop, and it just goes on and on and on and on and on until it eventually becomes a stable simulation, and it doesn't go through and do anything else. That's the point anyways, right? So I'm going to just call that the end of the tutorial. I will see you guys next week. If you liked it, give me a thumbs up. Comments go down below. Don't forget to subscribe. Tell all your friends. Don't forget to visit my Patreon. Patrons get special access to stuff. You guys can get the download source code projects and all the assets that I create, and all of that will be available to you there. If you have questions, feel free to ask. Hit me up on Patreon. I don't always check YouTube comments. It's a little overwhelming sometimes. What else? That's it. I'll see you guys next week.